Hey folks, welcome. So this session is dedicated to solve linear programming models and basically to solve the problems and to create models. Linear programming is actually used in a lot of these companies nowadays. It helps in resource allocation decision. It's a very important part of decision modeling and helps a manager to make better decisions. Um, so to solve a model, there are three steps. First is you formulate a problem. Uh, you By formulating a problem, I mean you have one objective function. Let's call it you have to maximize the profit, let's suppose, and there's a constraint to do that. Then you have certain constraints on how to maximize your profit that will be affecting your objective function. The second is you solve them. You can solve it through a number of ways. Let's suppose you can solve it through algebraically, you can solve it graphically, and then you can solve it through Google Sheets. So we have a couple of add-ons that help you do that. It can be solved both on Google Sheet and Microsoft Excel, and then finally you interpret it. Okay, now I'll give you an example how and where linear programming can be used. Let's suppose you are a manager in one of the manufacturing companies, right? And you produce two types of products, product A and product B. Now, product A gives you 10 rupees profit, product B generates profit of 20 rupees. Now we can clearly see that profit B is generating almost twice, almost, not almost, actually it's generating twice the profit of product A. So, and now you want to decide how much each quantity is to produce such that your profit is maximum. Your gut feeling would be you would say that let's produce more of product B than product A because it's generating you more profit. But that's not the case in reality, right? In reality, there are a number of constraints. The first constraint could be the cost. How much cost are you incurring to build one product? Product A might be um, costing you less than product B, and you have limited budget. The second constraint is the number of man hours. We don't know how much time does it take to build each product, and but one thing that we do know is that the time is limited and we have a limited number of man hours. We can't ask our employees to work 24/7, right? So we can only allocate certain number of hours in a month. That will affect how much of each quantities are generated. So we develop an objective function. The objective function is that you want to maximize the profit. The profit could, if I write it in a mathematical equation, that will be 10 times of A plus 20 times of B, which means A is the number of quantities of A that are being produced. B means number of quantities of B that are being produced. So 10A plus 20B is your total profit. Now you have to maximize this equation subject to certain constraints, right? So this is one of the mathematical problem that you would be solving in your field, and you can use linear programming to do that through this. So without further ado, let's jump to Google Sheet and find out how to solve them. So lucky for us, there is an add-on on Google Sheet to solve linear programming models. Let's find out. So this is the add-on Open Solver. I've already installed it. You can go and install it. You go to add-ons, find it here, Open Solver. Here it is, and uninstall and install. Okay, now I'll tell you one more interesting thing that I just saw from this graph is, so how would you solve it graphically? So we all know that now if I take this graph, these are the corner points. This is the corner point, this is the corner point, this is the corner point, and this is the corner point. Suppose you want to maximize the function. Where is this graph getting its maximum value? It's here, right, at one of the corner points. So this would be your answer. This is how we solve it graphically. But it's a very tedious task. We don't have time to solve it graphically. So this solver use the same algorithm to solve it. Okay, so just wanted to show you the mathematical form of linear programming. Let's jump now. Okay, so we have already installed Open Solver. I'll take an example how to create a model on Open Solver and then solve it. So I have two examples there. Let's start with the first one. So the first one says that you have to maximize the profit 2x plus y subject to 4 constraints. Now, very similar example that I just coded. This x is the number of quantities that you might be producing. Y is the number of quantities of y that you're producing, right? Subject to this constraint, 3x plus 6y is less than equal to 32. 7x plus y is less than equal to 20. 3x minus y is greater than equal to 3, and x and y should be both positive, which is obvious, right? So how to write this, I'll just let you know how to write this. So you have to just write x and y. Okay, so this is your variable. This is your variable. The values that you have is 2 and 1, 2 and 1. Okay. Constraints. The first constraint is 3x plus 6y is less than equal to 32. Okay, so 3x plus 6y is less than equal to 32. Okay. Second constraint is 7x plus y is less than equal to 20. Okay. 7x plus y is less than equal to 20, I guess. Yeah, 20. Okay. Third constraint is 3x minus y is greater than equal to 3. Fair enough. 3x minus 1 is greater than equal to, what was that? 3. Okay. And then we have x is greater than, x is positive, so x is positive, like it's 0, greater than equal to 0, and y is positive, so y is positive, greater than equal to 0. Now before I go ahead and solve this through solver, I want to make sure that you understand what I've written here. So there is this function in Excel which is called sum product. Okay. Now what is sum product? If you don't know what is sum product, I'll explain what is sum product. Now we know that our equation was that you want to maximize 2x plus y, right? So this is what I've written: 2 into x plus 1 into y, right? This is my objective function. This variable values that I'll be generated. I've used this constant values to find out what's my maximum function, right? Now if you want to write this 2x plus y, how you're going to do it, let me just tell you. There's this function for that which is called sum product. So I'll choose this row and then I'll choose this row. I'll put it as static. I'll tell you in a minute why. Okay. Now what is this value is 2x plus y is what is this particular value. So this sum product is nothing but 2x plus y. 2 times of x plus 1 time of y is this value. Okay. Now this constraint was 3 times of x plus 6 times of y is less than equal to 32. How am I going to write it? Same sum product. So let me just stretch it down. So this is why I've put it as, if you see, I've put it as static, because this row is anyway going to be the same. Only these values are going to change. Okay. Fair enough. So 3x plus 6y is less than equal to 32. This value is 7x plus y is less than equal to 20. This value is 3x minus y is less than equal to 3, is greater than equal to 3, and x is greater than equal to 0, and y is greater than equal to 0. Okay. So these are my constraint. This is my values, and this is my variable cell. So let's now begin it and solve it through Google Solver. So I'll open the sidebar. Okay, here it comes. Now it asks for my objective cell. What is my objective cell? Now this is my objective cell because this is the value that will be generated, right? 2x plus y, this is my objective. I'll just update it here. I want to maximize this. Yes, I do. And what's my variable cell? Variable cells is nothing but the values that are not constant, right? So variable cell is, you want to find out the values of x and y. That's variable for you. So you'll just select this and you'll add it here. Okay. Now constraints. The first constraint is 3x plus 6y is less than equal to 32. Okay. So I'll just add new constraint. So this value, 3x plus 6y value should be less than 32. So this value I'll just update it. Should be less than, it's already less than equal to this value 32. I'll just update it and I'll just save it. Next constraint is 7x plus y is less than equal to 20. So the value of 7x plus y, which is this, should be less than equal to 20, which is this. I'll save it. Next constraint is 3x minus y is greater than equal to 3. So the value of 3x minus y, which is this value, I'll select it, is greater than equal to 3, which is this value. Okay, I'll save it. Next constraint is x is greater than equal to 0. So whatever value of x, which is this, should be greater than equal to, I think I made one mistake. I have to check because I did not save. No, it's fine. I thought I did not do that, but it's fine. It's greater than equal to. Fair enough. Okay. Now I'm going to add new constraint, which is y is equal to greater than 0. Here is it. It's greater than equal to this value, which is 0. I'll update it and then I'll save it. So as you see, my objective cell, which is D3, should be maximum. So the value of 2x plus y, which is this essentially, 2x plus y should be maximum. I want my profit to be maximized. What values can change? These values can change. So this value is what my solver is going to give me. Okay. So these values, x and y values, can be changed. So these are my variable cell. If you had third variable, let's suppose z, then these values would have been your variable value. For now we don't have. Let's remove it. And your constraint. Okay. We have checked it. We've done it. Let's solve the model. So it's solving. You can see it's building model. And it is solved. So 2.3 times of x plus 3.9 times of y is giving you 8.5 profit. Okay. Now obviously you can make it an integer. There could be another constraint wherein you want it to be integer. This integer. For now, let's just round it off. So 2 quantities of x, 4 quantities of y will help you generate the maximum profit. So this is how you solve a linear programming model on Google Solver. Let's go with another problem that I have. This is a word problem now. Now, this says that a college department head must plan the course offerings for the next term. Student demands make it necessary to offer at least 20 courses. Now focus on this at least word. At least 20 core courses, each of which counts for 3 credit hours, and 20 elective courses, each of which counts for 4 credit hours in the term. Faculty contracts dictate that total of at least 60 course and elective course, 60 core course and elective course, and at least 205 credit hours be offered. Okay, for each course taught, each course taught cost the college an average salary of $2,600 in faculty salary, and each elective course costs $3,000. How many each of course and elective courses should be scheduled so that the faculty salaries are kept at a minimum? Okay, so you want to basically minimize the total salary. Now let's first write down the equations. So my objective function is minimize the salary. Okay. Now what is the total salary? So let's suppose C denotes total number of core courses and E denotes total number of elective courses. Okay. Let's first write down our objective function. Objective function is you have to minimize the salary. Now faculty salaries, we know that 2600 is your core course faculty salary. So 2600 C plus 3000 is your elective faculty salary. So 3000 E. So this is your objective function and you have to minimize this. Okay. Now subject to, we see a lot of constraints here. Subject to constraints, the first constraint that I can see is students' demand makes it necessary to offer at least 20 cores, each of which counts for, and 20 elective cores. So I need at least 20 core cores. C, which is core course, should be greater than or equal to 20. Similarly, elective course should be greater than or equal to 20. This is my first constraint. Second is faculty constitute a total of at least 60 courses. And so this is my second, total of at least 60 core and elective courses. Fair enough. C plus E greater than or equal to 60. Okay. Now another constraint is on the total credit hours. So I know I can only give 205 total credit hours. So we know that core courses for 3 credit hours and elective courses for 4 credit hours. So 3C plus 4E at least should be greater than or equal to 205. So this is my objective. So this is my objective function subject to these constraints. And I want to find how many core courses can I give and how many elective courses can I give. Let's start building the model on here. So I'll just write core, elective, my variable cell, and what are the values that are given. So values are 2600C plus 3000E. So 2600C and 3000E. I'll just put this as, okay. What are the constraints? So the first constraint is C should be greater than or equal to 20. Core should be greater than or equal to, so 1, 0 should be greater than or equal to 20. Fair enough. Similarly, the other was elective should be greater than or equal to 20. So elective should be greater than or equal to 20. Fair enough. Next is C plus E. Total should be at least 60 courses. Okay. Fair enough. So 1, C plus E, 1 plus 1, we are equal to 60. Okay, fair enough. And third condition is 3C plus 4E should be greater than or equal to 25. So 3C plus 4E should be greater than or equal to 205. Okay. So this is what it is. Now I'll use the sum product. So this row with this, and I'll just put it static. Okay, and I'll just stretch it down. Now you see this is for this first constraint, this is the value of the second constraint, this is the value of the third constraint, and this is the value of the fourth constraint. Okay, now let's create another model and change it to current sheet. Okay, so what's my objective cell? This value is my objective cell. I'll update it. I want to minimize the total cost, so it's already selected. Fair enough. Now variable cell, this is my variable values that will help me generate. I'll add it. Okay, now coming to constraints. The first constraint is C should be, core courses should be at least, so the value of the core course is this. I'll update it. It should be greater than or equal to 20. I'll do that. I'm sorry, I have to put this in center as well because I have a little OCD. It's bothering me. Okay, so I'll just save it. That's the first constraint. Coming to the second constraint. Okay, I picked up the second constraint. It tells me that it should be greater than or equal to 20. It should be greater than or equal to 20. It's done. I'll save it. Third constraint is total number of courses should be at least 60. Okay, the value, this is the value of the total number of courses. I'll just update it. It should be greater than or equal to 60, which is this value. Let's just update it and I'll save it. Now total hours is should be greater than or equal to 205. So this is the value of the total hours. I'll update that. It should be greater than or equal to 205, which is this value. I'll just update it and I'll save it. Okay. This is the value. Let's just solve the model. Okay. So this has solved the model. Now we can even verify it and interpret it. It says that I need 35 core courses and 25 elective courses. Okay. And if I take 35 core courses, 25 elective courses, the cost that will come is roughly around 166,000. Okay. Now let's check the constraint. So 35 core courses, which is this, is greater than 20. Yes. Second is 25 elective course. It is greater than 20. Very well. Third is the total should be 60, which is 60. You can see the sum here. It is 60 and it is greater than or equal to 60. The total number of hours is coming 205 and it was asked to at least be 205. So it's following this criteria as well, right? So this is how we solve the linear programming model on Google Sheet. Just to give you one last thing, most of the times you might get an error wherein it tells you that it cannot solve. If it comes, you can just get a hint that you have very limited number of constraints, right? So it's not finding any corner value, so you need to get more constraint. I have tried solving some of the problems and it gave me uh, that it cannot be solved. Either there's a problem with your objective function, either it just cannot be minimized or cannot be maximized, or probably you have limited number of constraints equation and you need more and more constraints for a better. So more number of constraints, the better your model is. Okay. So this is how you create a linear programming model, how you solve it through Google Sheet, and very useful in your day-to-day life as a manager, as a student, as a faculty, anything. Okay. So this is it, guys. Anything else that you would like to know from me, please mention. I'll help you teach. The next video would be about non-linear programming, and I'll upload that once it is ready. Okay. Thank you.